All right, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please channel and leave a like for this lesson. Now, in today's lesson, we are looking at vectors. Specifically, we're going to look at the resultant vector. And you may already have an idea about what vectors are. So suppose we have an XY plane like that. And a vector is simply a line in a particular direction. So that is how we represent a vector. Okay, so now the length of this line is basically from the origin to where the arrow ends, and that is what we call the resultant of the vector. So we can just cut this here. So that is basically what we call the resultant. So it's basically just the length of this line from the center there to where the vector is ending. And how we find that resultant, we just look at the distances the vector travels in the y-axis and in the x-axis. Let me use a different color. And in the x-axis. So we're going to have y components and x components there. So x and y. So basically the resultant r, or the magnitude of the vector, is just given by the square root of x squared plus y squared. So the x part squared plus the y part squared. So that is how we find the resultant, or the magnitude, or how big the vector is. Okay, so that is the formula that we use. Now, there is another concept that you should know on vectors, and that is the direction. So this is how we find the magnitude. So it's a magnitude. Let me just increase the pen size there so that, so we say magnitude. Okay, so that is how we find the magnitude. Then now there is also finding the direction of the vector. Direction of the vector. Okay, so the direction of the vector is simply the angle theta, which is this angle here. So when you have your y and your x, theta, which is the direction, is just basically the tan inverse of the y part over the x part. Okay, and once you evaluate that, that will be your direction. So magnitude is given by r. So magnitude or resultant. So these are terms you should get used to: magnitude, resultant, resultant vector. So vectors that we should know about: velocity is a vector. We have acceleration. Acceleration is a vector. We have a force. Force is a vector, and so on and so forth. Now, this is very important because what we'll be looking at specifically today, I think we can start from simple, then we build on from there. So let's see if we have a question like this one. So let's say you are asked to find the resultant and direction of the following vector. Okay, the following vector. So I'm going to have my XY plane there. So this is my XY plane. Then I'm going to have my vector in yellow. So just say from here, like that, like that. So that is my vector. And I've been given that the endpoint here, just put, so the endpoint here, that is, let's say 5,6. Okay, So I've been given that the end point of this vector is 5, 6, and the starting point is 0, 0 there. So that is the starting point, 0, 0. Then now I need to find the resultant. So to find the resultant, I need the distance in the x-axis. So in the x-axis, that is from here to there. So we see that what corresponds to the x-axis at that point is 5. So this distance is 5. And I'll just put the 5 there. Just erase this. So that is 5. So that is the distance in the x. And we also need the distance in the y-axis. So from here to there. Okay, so let me just highlight from here to there. Okay, so this is actually a length of 6. So this length is the same thing as this length that is here. So we can just project it here and put it here. So this is a length of 6. Okay, so we have our lengths. So we can simply say the resultant is just the square root of the x part squared plus the y part squared. So which will be equal to the square root of, so the distance of the x, that is 5. So let me use the color for, so that would be 5 squared. Then for the y part, which is this length, which is equal to this length here, so we just project it here, that is plus 6 squared. Okay, so that is 6 squared. So now we can simplify and find our resultant as root of, that will be 25 plus 36. So 25 plus 36, this will give us root of 61, and we can evaluate the root of 61, and it gives us about 7.81024.9. Then we can round off as 7.81. Okay, so that is the resultant. Then now the angle, so the angle theta, just drag it up here. So the angle theta is basically the angle from the positive x-axis. So always remember that angles are measured from the positive x-axis going to meet where the vectors are. So that is how we measure angle for vectors. So the angle is always from the positive x-axis to where the vectors are placed. So the angle theta, which is from the positive x-axis to where the vector is theta, which is equals to tan inverse of the imaginary part, or the y part. So that is the y part over the 5 there. So that is the y part over the 5. So anyway, just connecting thoughts here. So that would be tan inverse of 6 divided by 5. Yeah, so just make sure that your calculator is in degrees. So yeah, so make sure that your calculator is in degrees, and this gives us 50.19442.891 degrees, which approximates to 50.19 degrees. And that will be the direction. So direction. So that will be our direction, and that will be our resultant force. Now, there may be more than one force acting on an object. So I'll give an example here, and you'll be asked to find the resultant force and the direction an object will move. So for instance, if we have, I'll put my x or y plane here, or let me just start with maybe a box. So let's see, I have a box here. Okay, I have a box like this. Then I have maybe one student pulling horizontally in this direction with a force of, let's say, a force of maybe 10 newtons. and we have another student maybe pulling at on this direction here, which is 30 degrees to the let's see, so we have that. So this is 30 degrees, at 30 degrees to the horizontal. So at 30 degrees to the horizontal, and they are pulling with let's say 50 newtons. And maybe we have another student pulling. Okay, I'll just put it here. Okay, so let me put a straight one. So they are pulling in this direction. Okay, and yeah, so that is the direction they're pulling, and this makes the angle let's say 17 degrees from the horizontal to the, yeah. And then we'll put one more student pulling down like that, one more student pulling down like that. Okay, the particular angle. So yeah, so suppose this angle here makes 90 degrees with the horizontal like that. All right, so now for us to find the resultant and the direction. So suppose you're asked to find, I'll use this, I'll use white. Find the resultant and direction. So I'll put numbers here. So this is let's put this as 30 newtons, and I will put this as 15 newtons. Okay, so we have everything. Let me just use the respective colors. Okay, so this is 15 newtons. So we have this object being pulled in different directions with respect to different forces. So now what we should do is we'll take this information on the x or y plane, and that is basically we'll take the angles as they are. So let me just do it first here, so I can just make these meet. So I can just join them like that. So join them like that and that. Okay, and basically the angles will be the same. So this will make the same angle to this one. So this will be pulling at 30 degrees. That is if we extend the lens there. So this one, yeah, let me just do this. So this will be, this is so that is 17. So this is how lazy I am. So that is 17 degrees. Let me just write it out. So that would be 17 degrees to the horizontal. So let me just draw my simple x or y plane. I'll use this. So we're drawing the simple x or y plane. So this is let me see. Okay. So this is x-axis or the y-axis, and this is the x-axis like that. Okay. Then I can remove the box there. Just do this. So I can remove this. Okay. Okay. So, but you have to draw it separately for you. So this is what we are going to have, and basically These are their lengths. Put it here. So that is okay. So we have that. So now for such a question, what we have to do is we need to resolve the forces into what we call components. Okay. So we have different forces. So this is at 17 degrees with the horizontal. So this is 17 degrees here. So we need to resolve these forces into components. Okay. So components. So we need to have two components, x component and the y component. So after doing that, we've done away with the drawing. So, but you write it out. So after doing that, you need to have two components of these forces. That is the x component and the y component. So you just draw a simple table down here. So you say x component, we'll use white for x component. So you need to have x component forces and y component forces. So that is x component, x component. So for the x component, force in the x is equal to the particular force we are talking about, cos the angle at which the force is at. So let me just zoom in there. So the particular force we are talking about, cos cos the angle. So that is how you find how you resolve forces in the x component. And in the y component, I'll use yellow. In the y component, the force in the y are equal to the particular force we are looking for, sine the angle at which that force is at. Okay, so now for each of these forces, we'll write them into two components. So we can start with this. So always remember this. Okay, this is something that you should always remember. So this is where we start from. We start from the positive x-axis, and this is at the point where the angle is 0 degrees. So when considering our angles, we always start from the positive x-axis. So this is where our 0 degrees is, and we go positive in that direction like that. Okay, so now, so we see that our first vector, which is 10 newtons, so we'll say the first vector, which is 10 newtons, so we say 10 newtons, 10 newtons, cos the angle at which it is at. So this is at in the x-axis, so this is in the angle 0 degrees. Okay, then we'll just repeat the same thing here. Whatever we've written here, we'll repeat it here as well. So that will be 10, but the difference will be now sine 0 degrees. Okay, then we go to the second one, which is this one. Okay, so remember the angle is always from the positive x-axis to where the force is acting. So the second one is 50 newtons, so that would be 50 on the x, that is cos. And what angle is it at? So we measure from this point, which is the positive x-axis, until we get to there, so which is just 30 degrees. So we say 30 degrees. Okay, then we repeat the same thing here, which is just 50. Now it will be sine 30 degrees. Okay, now we do the same for this one. So this one is 30 degrees. So the 30 degrees, which is this one, I mean 30 degree magnitude. So that is 30 magnitude. Now, what is the angle at which this vector is at? So remember, we always measure from the positive x-axis to get there. Okay, so now what is this angle from here up to there? So we've been given that this part is 17 degrees, and we know that this straight line is 180 degrees. So this angle will just be 180 minus 17 degrees. Okay, which is 180 minus 17, which is 163. So this angle is 163 degrees. So always measure the angle from the positive x-axis until you get to the vector. So this angle here is 30 degrees. So this will be cos 163 degrees. Then we repeat the same here, it will be 30, but it will be now sine 163 degrees. Okay, oh, I've written something else. 163 degrees. Okay, then now let me just extend the line like that. Okay, and now we can do the last one, which is this vector here. So again, we measure from the positive x-axis until we get to the vector. So the angle, so this is 15 newtons. So we say 15 newtons cos, what angle is it at? So we measure from the positive x-axis until we get there. So this angle, what is this angle? So this is 90 plus 90 plus 90, which is just 270. So this will be cos 270. Okay, and here it will be 15 degrees, 15 newtons sine 270. Okay, so here we have resolved forces into x and into y. We can simplify each of these forces, so we can just do it here. Even here, it's no problem. So what is 10 cos 0 degrees? So cos 0 degrees, that will just give us 1 times 10, that will be 10. Okay, then here sine 0 degrees, that is 0 times 10, that will be 0. Okay, then here we have cos 30 degrees, that is 0.866. So that is cos 30 degrees times 50. So this will give us 43.3012. Okay, then here we do the same. So this will be cos sine 30, that is half. So this will give us 25. Okay, so that will give us 25. Then we do the same here. So cos 163, so that is cos 163 degrees. That is giving us negative 0.95. So times 30, that will give us negative 28.689. We do the same thing here. So this will give us sine 30. So sine 30, sine 163, sine 163, which is 0.292371. So times 30, that will give us 8.7711. Okay, so we do the same even for the last one. So cos 270, that is 0. So this will give us 0. Then this will just give us negative 15. Okay, so now we have the forces and the components. Let me just clean it a bit. All right, so now after doing that, we can now add. Okay, so we can just add. So we'll say the forces in the x. So we say the forces in the x. So we just say forces in the x will be equal to, so we add this, so that is 10 plus this minus this. So that is 10 plus 43.302 plus negative this plus this. So this will give us 24 point, what's that? So 24.6122. Okay, then we do the same for the y component. So forces in the y will be equal to 18.771. Okay, now that we have our forces in the x and our forces in the y, we can now find our resultant. So our resultant, just as usual, will just be equal to the forces in the x squared plus the forces in the y squared. Okay, so we just put the root of the forces in the x, which is 24.6122. We square that plus the other one, which is 18.771. Then we square that. Then we simplify. All right, so simplifying everything. So we square this, we add them, then find the square root. We get 30.95. So that will be in newtons because we are looking at it from newtons. So if it was velocity, it would have been meters per second and so on and so forth. So now we are done with the resultant. Now we can find the angle theta. So theta, remember, is equal to, or we find the direction. So the direction here, we were looking for the resultant force. So the resultant force, resultant force. Okay, so this is the resultant force. Now we want to find the direction. Okay, so the direction, basically theta is equals to tan inverse of the y part over the x part. So the y part we have, so this would be tan inverse of the y part that we have is this one, 18.771. So that is let me just color code it. So that is 18.771 divided by the x part, which is at 24.6122. Okay, so now we just find the tan inverse of that. So this is a tan inverse, and just make sure that your calculator is in degrees. 18.1771 divided by 24.6122. Okay, so this will give us about 30 degrees. So this is positive 36.447 degrees. So this tells us that this object that is being pulled will move actually in this direction. Okay, and it will have a resultant, because 30 degrees is in the first quadrant, so 36 degrees is in the first quadrant. So when this object is pulled, so when it's pulled, it will actually move in this direction. So it will move in that direction, and it will have a direction of 36 degrees, and the magnitude of, so the magnitude of 30 as well, 30.9. That will have the magnitude of 30.9. Okay, so that is how you deal with such questions. Let me just put up one question for you to try out, then we'll move on from there.